Welcome back to my channel Subject-o-Phile. Today, as you can see on the screen, we are going to discuss a concept in the chapter Matrix and Determinants, which is very important in JEE Advanced perspective if we see. It's a very important chapter as well for JEE. And today we are going to learn a very alternative method to find the inverse of any general matrix. Not let's say by general I mean not just 3 cross 3 or 2 cross 2 order matrix, but also 4 cross 4, 5 cross 5, any n cross n matrix. So for that, let us first revisit what is actually inverse of any matrix. By definition, we know that for any matrix A, inverse of A exists if and only if exists if and only if A is non-singular, which means that the determinant of A is non-zero. It's the most fundamental criteria for existence of inverse of any matrix. The second point says for any invertible matrix A, there exists another matrix B such that the dot product AB must be equal to the dot product BA, and it should be equal to the identity matrix of that same order. So for such case, we can say B is the inverse of A, and it is denoted by this sign, which is A inverse. So a very necessary criteria is also A must be a square matrix. You can essentially guess that by the sense that we only define determinants for square matrices. So yeah, now let us first know or understand a very simple method which each and every one of you will know. The first method, which is basically taught everywhere to find the inverse of a matrix, and in coaching as well as everywhere, you use this method to find the matrix, the inverse of a matrix. So the first method employs the concept of adjoint of a matrix. As you can see, adjoint of a matrix, which is denoted by this adjoint of A, which is basically transpose of the matrix of cofactors of the elements of matrix A. You guys all know it. Adjoint of A is the transpose of the matrix of cofactors of the elements of matrix A, which is denoted by Aij, where I represents the row and J represents the column of the matrix A. So now, what is cofactor of the corresponding elements Aij? It is nothing but -1 to the power of I plus j, and determinant of a submatrix, which is denoted by this. Now, what is this submatrix? I would tell you. This is just a notation, don't be scared of it. This is just a notation. So it denotes the determinant of the submatrix of A. This is the submatrix, and we can see that we are actually taking the determinant of that submatrix. This submatrix of A is nothing but the matrix which is created out of the original matrix A by removing the ith row and the jth column from that matrix A, which will give us the submatrix for the corresponding element Aij, for which we are actually interested in finding the cofactor. So this is the adjoint of the this is how we find the adjoint of matrix A. So, and we can see what is this notation denotes and how we find the cofactor of each and every element of the matrix of matrix A. So ultimately, after finding all this, we can actually compute the inverse of the matrix A, which is denoted by A inverse. That would be adjoint of A divided by determinant of A. This is the formula that we know for calculating inverse of a matrix. Now in perspective of J, you have only used this for 3 cross 3 matrix, because you know the formula for finding the determinant of a 3 cross 2 matrix, but you have no idea how to find inverse if we ask for a 4 cross 4 matrix or 5 cross 5 matrix or any in general n cross n matrix. So okay, so we are going to deal with that as well, and you're going to understand why. That is one of the point for which this method, I think, is not employed for in finding inverse of any general matrix A. So let us understand it with a concept, with a question. First we will use this first method to solve this question, and similarly after learning the next method, which is the alternate method, as I said, we will again solve this same question to check whether our method is correct or not. So here the question says find inverse of A, which is this matrix 133, 143 and 134, and this question has been taken from NCERT class 12 book part 1 in page 130, as you can find that. So first, as this method goes on, we verify that mod of the determinant of A is not equal to 0, then only we can find the inverse. So by calculating determinant of A, we find that it comes out to be 1, which is non-zero. So this matrix is invertible. If the matrix A is invertible. So now we find the adjoint of A by the similar process of finding cofactors of each and every element. Let's say what is the cofactor of the first element, which is the 1 1 element, from the first row and the first column, that is the element 1. The cofactor of the element 1 should be this matrix, this submatrix, as per the definition, right? So here the hidden term is -1 to the power 1 plus 1, which comes out to be 1 itself. That's why I have not written anything. It is plus 1 basically, and then we have written the submatrix here. So this total thing is the cofactor of 1 in the matrix A. Okay, so and this entire matrix gives us the cofactor of each and every element of A. And obviously we should not forget, which is a very common mistake made by students, that they forget to finally do the transpose at the end. So we have written the transpose here so that we don't forget at the end. So we find out each cofactor of each and every element of A, just like here, absolutely with the sign. We don't forget the term -1 to the power I plus j as well. So here you can see like this, and after doing all this, we can compute the determinant easily, like 4 into 4, 16 minus 9, it gives us 7. Here also 4 into 3, 4 minus 3, which gives us 1, and there is minus sign, so it is -1. So similarly we get this matrix, and then finally for finding A inverse, we know it is adjoint of A divided by mod of A, wherein we had mod of A as 1, so it is 1 by 1, and we have this adjoint of A as obtained from above, right? So after this we after computing this, we find the inverse of the matrix A comes out to be this is our A inverse basically. So we have this answer, and we have you all know this method very well, because you are familiar with this. You have learned it in your classes as well, to use this method to compute inverse of a matrix. But now I'm going to show you a different method, rather, which I find to be easy and short. Basically this method which I'm going to show you is not a new method to you. Probably just you overlooked it because you have nobody teaches you this method, or nobody has shown you the importance of this method. This method has been shown in your NCERT textbook, but probably you never took it seriously, right? So in simple terms, we will use the concept of elementary row operations in order to find or compute the inverse of this matrix, and this is derived from two very fundamental concepts of linear algebra. That is the course in your first year engineering college that you will be learning for matrix algebra, that is RREF and GJE. RREF stands for row reduced echelon form of a matrix, and GJE stands for Gauss-Jordan elimination. So you don't need to get bothered about this terms. That is basically when you will take up the course of linear algebra, you will get to know about it in details. Now let us first just answer a very important question that must be coming to your mind right now, that why do we choose this new method over method 1, which we have been already conventionally learning everywhere. So for that, I have written some points which you can read. Like, for the first point, we can avoid the tiresome task of finding adjoint of a matrix. As you can see over there, it was a big matrix. You have to write the cofactors of each and every element, and also it becomes very tough for writing all that if the matrix gets bigger. I mean, it is greater than 3 cross 3 order. So it's a tiresome task. The second process, we don't actually know formula for calculating determinant of any other matrix other than 3 cross 3 or 2 cross 2. So how do you deal with the determinant of such matrices where the submatrix comes out to be 4 cross 4 or 5 cross 5? So for that, we can actually calculate the determinant, but you don't know the concept in your J level. So that is basically the use of permutations and transpositions that you will learn in linear algebra course. I have just written or showed you the formula that actually takes place to find it, which we use to find the determinant of such general matrices, but you don't need to get scared about it. It is not of any relevance to your J syllabus. So it can be written as a summation of sine of sigma, where sigma is a permutation function. It is basically a bijective function, as I've written here, that maps the rows of a matrix with the column of the same matrices. So for example, if I talk about the first row, which is the row 1, we can map it with any of the n columns present in the matrix. So for each of the n rows, we have n mappings possible. So the number of permutations possible, which is given by this set Sn, is basically n factorial. So we have written the cardinality of set Sn is n factorial. And similarly, by this same concept, we can deduce, or we can say that since this is a bijective mapping where the number of rows must be equal to a number of columns for the mapping to be bijective, we can say that the determinant is only defined for square matrices and not for any other matrices. So you might have seen that we only talk about determinants in square matrices, but you also must have pondered about why we can only talk about determinants in square matrices. So this is the reason for why we can only find determinants for square matrices. It comes from the fundamental concept of permutations and transpositions that you will be probably learning in your college first year. So the third point which comes here is, clearly we don't want to use the above rule to find determinants every time we are told to find inverse of a general n cross n matrix. You can see even this formula is so big. If you like this, so there will be n cross n Samans, and how will you like sum n cross n terms? Not n factorial terms. How can you sum n factorial terms? There will be n factorial possible terms here for n cross n matrix. It's a very tiresome process, right? So you won't be able to do that. So moreover, a very common mistake which is also made by students, as I already mentioned, that they forget to perform the transpose of the matrix at the end to find the adjoint. So that also creates a lot of mistake while finding the inverse. So in order to avoid all the above problems that I discussed above, we can use method 2, as it only employs simple arithmetic elementary row operations to compute the inverse of any general matrix. So here you don't need any kind of determinant, any kind of adjoint concept, anything. You just need to have some basic concepts about addition, subtraction and multiplication. That's all. You will be able to compute the inverse of a matrix. So before going to that, we first let us know a new terminology which is very simple. It is augmented matrix. So what is an augmented matrix? So it basically concatenates two different matrices end to end, with which essentially have the same number of rows to give a single matrix. Okay, for example, if A is a 3x3 matrix, as you can see, and B is a 3x1 matrix, so we can see that they have essentially the same number of rows. Same number of rows. So we can basically concatenate it end to end to give a single matrix. This is a single matrix which we are calling it as the augmented matrix, and we denote it by this sign. Okay, A, and then here it should have been capital B, not small b. Just pardon me. So this is capital B. Yeah. So this is how we are denoting the augmented matrix AB. Now we have learned the concept of augmented matrix. Now the second concept that will be used in this method is the method of elementary row operations. I have actually wrote all those things which have been mentioned in your NCERT only, because that is the basic or fundamental row operations that we are going to use even in this method. Nothing other than that will be used. So I've used the same notations as of NCERT. Which the first method say Ri to Rj, which means we are interchanging any two rows of the matrix. Okay, we are interchanging the ith row with the jth row of the matrix. Now I am transforming ith row to k times the ith row, which means we are actually transforming the ith row with the new elements, which is multiplied by k times of the original elements. So basically we are multiplying the ith row with some scalar k to get the new ith row. So that is another transformation by an elementary row operation. And the third transformation says that we are transforming the ith row, the elements of the ith row, by adding the elements, corresponding elements of the jth row multiplied by some scalar, say k, and then we are getting the new ith row. So this is the transformation. This 3 transformation is the basic thing which we are going to use for elementary row operations, and nothing more than that. So you can read it in NCERT as well, the same thing has been written. So without wasting any more time, let us just get straight to the question that we discussed above and verify that whether our method which we are talking here is correct as well or not. Let us discuss the same question which we have discussed above, and now let us try and to compute the inverse of this matrix A by this alternate method that we have just learned now. Okay, so basically actually I have not told you what we have to do in this method to compute the inverse. So here is that concept, stepwise how we can actually find the inverse of A. So first we create the augmented matrix, as I have told the concept of augmented matrix above. We create the augmented matrix AI, where I is the identity matrix, essentially of the same order of A, because we know we have to have the same number of rows to create augmented matrix. Now after that we basically perform elementary row operations in this augmented matrix AI such that the left hand side of the matrix AI becomes I now. So this side where it was A, it will become I now. This side, the left hand side, would now become I, and due to this elementary row operation, this right hand side which was I would obviously now get transformed into some other element, let's say B, some other matrix B. So whatever which would result out of this elementary row operation basically will be the inverse of A. So this matrix which would be actually created as a result of this elementary row operation in the right hand side would be the inverse of our matrix A. So this is the basic concept which I have written here. You can read it, you can pause the video and give it a read, and this will be better understand if I solve the question. So first, as you can see, we create the augmented matrix AI. This is A, you can see, and this is obviously I, the identity matrix I. So objective, as I said, transform this side into I, this the left hand side to I. In the process, whatever matrix will be left here would be A inverse. Okay, so the first step which we do to in order to complete or accomplish this objective is we transform the second row into R2 minus R1. It's the first step. So if I do R2 minus R1, 1 minus 1, 4 minus 3, 3 minus 3, we would get 1 0, 3 1, 3 0, and obviously 0 minus 1, 1 minus 0, and 0 minus 0 as well. So you can see we get this transformed similarly. Now in the second process we transform the third row into R3 minus R1. So 1 minus 1, 3 minus 3, 4 minus 3, 0 minus 1, 0 minus 0, 1 minus 0. So you can see we get this matrix as a result of this two process of elementary row operation. So now we can see this is close enough to I, but it is still not I, because we have to make this two element 0, and we can do it very easily by this two following elementary row operation steps. First we transform the first row into R1 minus 3 R2 to make this element 0. So in order to do that, after accomplishing this step, this elementary row operation step, we find that the matrix gets converted into this, the augmented matrix. So we see that this is very close to I now. Just we have to make this element 0. So for that we do the next step, which is R1, transforming R1 into R1 minus 3 R3. So by doing that we find that this side of the augmented matrix is now completely transformed into the identity matrix of 3 cross 3 order. So whatever matrix as a result of this 4 elementary row operation ends out to be here, which we say B, is basically, as per our concept or as per our method, is the inverse matrix of A, or A inverse, right? So we clearly write that B equal to A inverse, and this comes out to be 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. And after verifying from method 1, we actually see this is the exact same matrix that came out in the method 1. So we can confirm that this method is correct, and the answer or the inverse of this inverse of matrix A is this. So we see that this method is so easy. Just by doing some elementary arithmetic row operations, we can easily find the inverse of a matrix without even having the use of adjoint of a matrix, cofactors or determinants, etc., etc. So this method can be employed for any general n cross n matrix, like however large the matrix be. We can use this method to compute the inverse very easily, which is not possible for method 1. So by cross checking with method 1, you can see the matrix that came in our answer in the first method. This is the answer, and you can see the next answer also in the second method, which is absolutely the same. So by concluding this, I would like to know your thoughts as well in the comments, that which method you would prefer to use in your exams or whatever. I would actually prefer method 2, because it is quite easy and short as well. Rest, please also do share your comments, do share your thoughts in the comment section. I would be glad to know what you guys are thinking. And also I would like to wish you all the best as you are in the final lap for preparation for JEE Advanced 2025, which luckily the organizing IIT of JEE Advanced 2025 is my college, IIT Kanpur. So I wish you all the best for that. And to help in your preparation, I would be preparing some short videos just like this, concepts, and also some good questions from physics, chemistry, mathematics, to help you guys in this final lap of your preparation for JEE Advanced 2025. You can also comment in the comment section about what kind of topics or concepts you want to see in the next videos. I will be coming soon with those videos. So thank you for watching this video. If you have liked the video, please share this video and also subscribe my channel. Thank you until we meet in the next video.